when we're given a quadratic like this, and this is called a quadratic. Can anybody tell me why this is a quadratic? Anything with an exponent of 2 is a quadratic. So any kind of x squared, even if it's just x squared plus 1, or even just plain old x squared, is a quadratic. Now, if you're asked to factor the quadratic, a trinomial quadratic like this is going to factor into 2 binomials. So what I like to do is I start off by doing something what I like to call draw the butt. I know it sounds kind of funny, but it is drawing 2 little sets of parentheses like that kind of look like 2 little butt cheeks. Okay? Now, in there, since the variable here is x, and remember when we were doing the binomial times a binomial, we would do the first times first. That would end up giving us that first term squared. So I would put right away, I would start off with knowing that my first term here has to be an x for both of these. So that's the only way I'm going to get this x squared is if I do x times x. All right. Now remember in that FOIL process, first was the x times s, outer would be these outer ones here, inner was the inner ones. As a result, those 2 terms ended up being like terms, right? And we ended up having to combine them by adding the coefficients, which these numbers turn out being those coefficients. So we have to ask ourselves what 2 numbers are going to add to give us this, but multiply to give us this. Am I losing anybody on that? Okay, let's go back a second here, and let's look at an example. If I say, like, I have x plus 4 and x minus 7. Okay. First would be the first times the first, which would give me x squared, right? Outer would give me a negative 7x. Inner would give me a positive 4x. Last would be a 4 times negative 7, which is a negative 28. Now notice how these 2 terms add to give me a middle term of negative 3x. And these 2 terms are this number for the coefficient and this number for the coefficient, right? So I'm always going to end up adding these 2 to get that middle coefficient there. And the last one is always going to be the product of these 2. So when I'm going backwards, I have to ask myself what multiplies to give me this, but what adds to give me this. Does that make sense now? Austin, you're still having trouble with it, or?
I don't know how you got that Y.
That's a 4. That's my bad there. This is not related. This is a separate problem. It's just if I were multiplying 2 binomials. This is going back and looking at, and this should be a 4, and I'm only making it worse now, but that's okay, that's a 4. Okay? So now we ask ourselves, do you understand how we have to ask? So what multiplies to give us the 6? What adds to give us 7? And this is where our bell ringers should have helped us out here, because that's exactly what you were doing when you had to do when I gave you the top and bottom numbers on that bell ringer. Like when I gave you the top number here, it's like having a top number of 6 and a bottom number of 7 in our Diamond Math bell ringer. What's going to add to give us a 7 but multiply to give us 6? What 2 numbers? Somebody? 1 and 6. Both positive, right? Okay. So we would have a plus 1 and a plus 6. And this is the factored product of that trinomial. Okay, here we've got another trinomial. We're going to start off, draw the butt. We're going to put in the x's, because x times x is going to give us the x squared. What 2 numbers will multiply to give me a negative 2, but add to give me a positive 1? Well, remember, in order for 2 numbers to multiply to give me a negative, one of them has to be a positive and one of them has to be a negative. And the only factors of 1 are 1 and 2. Now, if I had a positive 1 and a negative 2, 1 times negative 2 would give you the negative 2. But would that add to give you a positive 1? No. So I would have to switch this and make it a positive 2 and a negative 1. Which, now, does it really matter which one I make negative and positive here? No, but I do have to make the 1 a negative and the 2 a positive like that. But it doesn't matter whether I put, if I write this as x plus 2, x minus 1, is it any different? No, the commutative property of multiplication says I can multiply in any order and still be the same thing. So it doesn't matter whether I start with the 1 over here or the 2 over here. The important part is that when I multiply negative 1 times 2, I'm going to get negative 2. And when I add 2 and negative 1, I'm going to get 1. Is anybody still lost on this? All right, let's try. Okay, now if you're confused here, the best way to start, again, it's still the best way to start is to start off by drawing the butt, put in the 2 sets of parentheses. All right? Then you start listing the factors of that last number. So the factors of 12, well, you could do 1 and 12, right? Then we 2 and 6, 3 and 4. Now that I've gotten up to 3, if I try and go any higher than 3, I'm going to end up repeating these, right? So these are all the factors of 12. Now, since this number is positive, we know that a positive times a positive will give us a positive. But is there any way we could add 2 positive and result in a negative? No. So if we can't add 2 positive to get a negative, what can we multiply together that when added together is going to give us a negative? Both of them have to be negative. All right, so we know at this point, from that, we know that these both have to be a negative. And the only 2 negative factors that add together to give me 7 are what? 3 and the 4. So we know we're going to have the x here, and a minus 3, and a minus 4. Now we can always double check our answers too when we're finished by doing that distributive property. X times x is x squared, x times 4 is negative, x times negative 4 is going to give me negative 4x. Negative 3 times x is going to give me negative 3x, and negative 3 times negative 4 will give me a positive 12. These two combine to give me that negative 7x, so it does work out. That's our double check to make sure that we factored correctly. It's always good to do that double check, especially when you've got more complicated numbers with lots of different factors. It doesn't hurt to do that double check to make sure you got it correct. Okay, so your question was, how do I know which ones we have to add to get and which one we have to multiply to get? Yeah. The last term here, this term, the constant, that's the one you have to, that's one you have to multiply to get.
Okay, so is it always going to be that way?
If you have this in standard form, yes. Now remember, the standard form is when you got the decreasing exponents. X squared, x to the 1, no x. As long as it's in that standard form, yes. If it got mixed around a little bit, you'd have to put it back into that order to do that. Okay?
What about if you have only the coefficients if you don't have a constant?
Okay, so let's see. Okay, so the question was asked, what if you had one that did not have a constant on the end, what would you do? Well, in this case here, this one's got 2 x terms and an x squared, which you would simplify first by combining these two like terms. So this would become x squared minus 2x. And then when it comes to factoring this, this is where you go back to the factoring the polynomial way of factoring. What's the common factor between this term and this term? The GCF would be the x, right? So we pull out the x, and we would get x times x minus 2. If you think about it, this is the same as saying x plus 0 times x minus 2. And the last terms here, when you multiply them, what do you get?
0.
So it's like having the plus 0 on here. So it kind of makes sense. But why would you go through that whole what multiplies to give me 0? And you just factor out the x and you've got your answer there. Does that make sense?
Yeah.
Okay. What we taught you just here with this only applies to quadratics of the form x squared plus bx plus c, where you have a number for b and a number for c, and it could be zeros, as we're saying there. But if you have something else in front of the x, something besides a 1 as a coefficient for the x squared, that's going to be our next lesson. Okay, you should not see any of that on the assignment right now. Nothing other than a 1 for the coefficient of the x squared. It's much more complicated when you have something like 2x squared plus 3x plus 7. It gets more complicated, and we'll talk more about that in a later lesson.